Moving right along on Rice Lake, our next speaker is Mike Michaud. He's a professional geologist with over 25 years experience in mineral deposit exploration, including gold, base metals, PGEs, and diamonds. He holds an earth science degree from the University of Waterloo and a master's degree from Lakehead. He had recently held executive positions with SRK Consulting, North American Palladium, St. Andrew Goldfields, and China Diamond Corp. Since 2012, he has been vice president of exploration for Sandgold Corp. His talk is Understanding the Structural Framework at Rice Lake and Implications for Near Mine Exploration Targeting. Mike?
Thanks, Mike. Good morning, everyone. I was just thinking on the way over here, and if you haven't had the pleasure of going outside yet, winter has definitely arrived in Winnipeg. So the Rice Lake mine, which is formerly the old San Antonio mine, has been around for approximately 80 years. And like most mines, with additional data, the ideas have changed, and what we want to do today is maybe just go through some of those recent ideas and where we're going and how that affects our exploration. Here's our forward-looking statements. I certainly will be making a few whopping forward-looking statements. Feel free to read this over. I hear it's good bedtime reading. Rice Lake, as I mentioned, it's been around for approximately 80 years. It's produced to date about 2 million ounces of gold, so that's fairly significant. It's located here in the southeast corner of Manitoba. And I would say, if you look at the pictures on the far right, this is the original shaft sinking, and this is prior to the invention of the hard hat. Today, where are we? We're growing production. We're at about 86,000 ounces per year. We have a total resource of about 3.5 million ounces. And interestingly, 2.5 million of those ounces were really discovered since 2006. So I would say this is a very interesting success story. And what we really wanted to do over the past year was to just try to better understand what the real controls on the gold mineralization are. So I won't dwell on this too long. I think Scott touched on this already and did a nice job. But what I'd like to point out is Rice Lake here, just northwest of the Ross River Pluton. This is in the western part of the Uchi subprovince. And the other thing to touch on here is there is a lot of gold mineralization in the area of Rice Lake and also to the southeast of the Ross River Pluton in this area. Small production over the past 80 years, but it's an area that's really underexplored. Red Lake is approximately 160 kilometers due east of here, so it's a belt with a lot of potential, and we see a lot more discoveries here over the next number of years. As we look at the more local geology, you can see that this is a package of volcanic rocks, intermediate to felsic volcanic flows, and volcaniclastics. They're generally east-west trending, north dipping volcanic packages. But I think the things we really want to emphasize here is that historically the Rice Lake mine occurs within the San Antonio mine unit, which is a gabbro layer. It comes down here, it's interpreted to come this way and up to the northeast. And this has really been the host of the mining over the last 70 or 80 years. And the recent discoveries are more in the hanging wall to that. And here you can see this is what we call the shoreline basalt. It's a basalt sitting within a package of intermediate and felsic volcanics and volcaniclastics. We also have a number of new showings and new mines in this area further to the hanging wall, which is in the intermediate package. And really what we want to understand is why are these deposits where they are? So this really prompted a structural analysis that we've been working on. And like I said, we're still working on this. The ideas are new and they're going to be further refinement. So bear with me on this model. But really, we compiled about 75 years of historic data. There's been over 1 million meters of drilling since 2006. So we have a lot of data to work with now. And what we really saw was once we collected the data, we brought out the lithologies, we mapped all the shearing, and we identified a number of subparallel east-northeast trending shear zones. And we were able to connect that from the underground workings and with the drill hole data. And what we've noticed is these shear zones seem to be spatially associated with the gold mineralization. Wherever we found a shear zone crossing a favorable lithology, something that was different was maybe more competent, or maybe the chemistry was different, this is where we seem to find the most gold mineralization. Now this is a busy slide. We're looking at plan view. You can see here's the SAM unit here. Okay, so there's north. This is northwest trending. The sand comes down here and swings around. There's a lot of data. I know it's a busy slide, but we wanted to show you we've scanned and able to digitize all of the old workings, and you can see that we were able to map the shear zones through the underground workings, through the drill hole, and further to the northeast. And this is where we found where these shear zones intersect these favorable units, like the SAM unit, like the shoreline basalt, and various areas here in the hanging wall intermediate volcanics. This seems to be where the gold mineralization is occurring. So when we overlay the geology map, it's pretty clear that these shear zones cross-cut all of the lithologies in the area. And these shear zones are fairly vertical, and this is only a selection of the ones that have been mapped so far. We still have more mapping to do in this area, as we have some deposits here, and over in this area, there hasn't been a lot of exploration, and that might be another area to find more of these east or northeast trending shear zones. So, to get started, maybe we can just have look at a few examples of the style of mineralization in these various areas. So the historic deposits, which is within the SAM unit, when we look in plan view, we can clearly see here's the 16 type shear zones, and here's the 38 type veins. And this all occurs within the SAM unit, which is outlined in white here. And you can see that quite clearly as well this is a composite plan view, and you can see the 16 shears here in blue and 38 more brittle veins here in red. Now, a close-up of those areas. This is the 16 type, which we believe is more ductile, and the 38 type, which is clearly more of a brittle deformation. And this is the type of veining here. And you can see an example. Here's 16 type, more of a shear vein, laminated, less dialites. Here's a picture of it here, quite nice in size. Here's the breccia vein. You can see the breccia starting to develop. The vein comes in, additional brittle deformation, and you get folding of these original veins. And you can see quite a bit of brecciation of those veins in this area. So what we believe is this is a clear case of a conjugate set of shear zones. We probably have close to north-south compression here. And as we have this compression, we have a conjugate set of breaks, this one being more brittle or more ductile, and this one being more brittle. Obviously, this northeast direction was favored over the northwest direction. So when we look at this in cross-section, you can see the SAM unit. We can see the various shears cross-cutting the SAM unit. This is one of the areas of the workings. You can see in gold, these are gold grades, and the red is the trend of this mineralization. And you can clearly see that there's some rolling of this vein as you go between the various shears. So to us, that indicates that this is reverse faulting, similar to what we have here in this idealized section. So we know that we have the north-south compression, and we have strike-slip faulting, but we also have reverse shearing as well. So this definitely complicates our mine planning efforts and our resource estimation methods. So now that we understand this, we know where to look to get the better parts of the veins, and it helps with our mining trends. So if we look at our more recent discoveries in the shoreline basalt, the L10 and the 007, essentially what's happened is the shear zones cross-cut this area, intersect this shoreline basalt unit, and we see a similar impact as at Rice Lake. We see the 16 shears developed, and we have the 38 veins developed as well. I would say what some of the differences we see is that because this is a basalt where the gabbro is maybe more competent, the basalt is a little softer, we start to see more shearing here and less brecciation. And these, in the attitude here of the host shoreline basalt, is a little steeper dipping than the San Antonio unit, which is moderately dipping to the north, and the shoreline basalt is fairly steeply dipping to the north. We see that the shearing that intersects this area seems to be a little steeper as well. And you can see again here in plan view, here's the Rice Lake deposit, or the SAM unit hosts the Rice Lake deposit. In this area, these shears continue to the northeast. They intersect this shoreline basalt, and you can see the red, how the gold is spatially associated with the shear zones and their intersection with this host lithology. What's interesting here is there seems to be a number of red dots or gold grades here outside of the shoreline basalt. And for us, that represents a good target. Again, you can see here in our plan view, this is our mapping from underground. You can see the plunge of this mineralization is quite steep, so it's a little bit different than what we've seen at Rice Lake. So this complication is important to know, because I think this leads to the exploration potential. What we see here again in plan view is we see here the shoreline basalt. Here's the Rice unit. We have a shear zone that comes across here. Now this could be the linking structure or the 38 veins that we typically see. But when we see this linking structure, it actually has a dip that goes to the south. It's hard to see here on plan view, but it's actually coming through the shoreline basalt and out the south side of the shoreline basalt. And where this shear goes, we're not sure, because we have never explored out here. But if it is a linking structure like we believe, there has to be another 16 shear coming down through here. And if it does, that means this 16 shear can come through here and possibly intersect the SAM unit and then start to produce the same type of mineralization that we see at the Rice Lake mine. So for us, this represents a very, very good target because the Rice Lake mine's average grade was over 0.3 ounces per ton. So certainly the SAM unit reacts very well to any type of shearing. Now, if we look at this on cross-section, this is looking to the east. We can see the San Antonio unit here. Here's the shoreline basalt. Here's the shearing, the different shears. Okay, they're oblique to this cross-section, but it's coming through the shoreline basalt where we have good mineralization in the 007 deposit. It continues vertically to here, and it should continue right into this area. So this is what we believe is going to be a very good exploration target for us going forward. Now, if we look further to the north again, this is intermediate volcanics, and we're trying to understand why we get these deposits out here. I mean, we seem to have a pretty good idea of the shoreline basalt and the San Antonio mine unit, so why are these just sitting in this massive block of intermediate volcanics? Well, when we started to map out the different lithologies and where the mineralization was hosted, you can see the section of core here. The best mineralization that we see at L13 in the hinge deposits occurs within this intermediate crystal tuff. And if you see this rock underground, it's very, very solid looking. So it's something that we believe may be the reason why this gold mineralization here, maybe this unit is just a little bit harder. We're starting to delineate these crystal tuffs now and where they intersect the east-northeast shearing, and this is where we should expect to see more mineralization. So that's really the three different styles of mineralization that we see. And we've put this model to the test. We started doing this about 6 months ago. So we mapped out these shears and we thought, well, we should follow them out now. And wherever they intersect the shoreline basalt, we should do some drilling. And sure enough, we did that. We went out there and we drilled these off. And we found these 4 new zones. Now, we only have a few holes into these, but you can see some pretty good results so far from each one of these 4 zones. So that's certainly going to represent, more exploration drilling going forward here. And as I mentioned, there's Cartwright up here. There's some other showings up here as well, and we need to continue to map out these zones and see where these northeast structures go. So I think that's one horizon that we're really going to be concentrating on going forward, because if we can find anything in here, as we're mining right here in L13 and Hinge and 007 and Rice Lake now, anything we can find here we can develop relatively quickly, and we can get access for drilling for the underground. So that's certainly one of our priority targets. I think the other targets that we have here really is this 007 target, where we can possibly get into another 16 structure that comes back and intersects the Rice Lake unit here or a San Antonio mine unit. I think that's a very good target. I think that could represent essentially another Rice Lake deposit. I mean, it's just a fabulous target here. The other areas, of course, are in this area of the intermediate volcanics where we found the Hinge and L13. So really what we're looking for is doing some drilling trying to identify and delineate the more competent units there, the crystal tuffs, and their intersection with these east-northeast trending shear zones, and that's certainly going to be a target as well. Now, there's one other target area that we really haven't discussed, and it's right in this area between the shoreline basalt and the Rice Lake mine unit. And from underground in the Rice Lake, now we have access to test some of the areas in here. And sure enough, what we did find in here was we found another subparallel basalt horizon. So it's in between the shoreline basalt to the north and between the Rice Lake unit to the south. So this represents another target. So you can see here that we're mining the 710. We've been drilling in this area. You can see some of the values, 26 meters at 8.5 grams. That's pretty good. And 13 meters of 25 grams. So this is a very exciting new area. And what we're hoping is going to happen is this comes here on the east-northeast structure. It's diffracting here, or it's starting to form maybe what's going to be a repeat of the 1638 structure across this unit. And our mining is right here now, so this is something that we can bring into the mine plan before the end of the year. So I think this targeting has worked really good. I mean, we have 4 styles of mineralization, and we're chasing them all up. So really what I wanted to say is that the Rice Lake mine, even though it's been around for 90 years, we have a lot of potential for additional discoveries out here. So thank you very much.